All right, I am going to solve this equation, and I'm going to attempt to do it in a way that maybe a lot of people wouldn't. We'll see. I feel like me thinking that other people are going to do the same thing. So I'm actually going to start by dividing out this 4. This is a strategy that I feel like we're always taught to distribute, but a lot of times it's nice to just, divide out or clear that on both sides when it makes sense. Does it make sense in this case? I don't know. Maybe not as much, but still kind of want to show that this is an option here. If I divide out the 4, I have to do that on both sides of my equation. And on the left-hand side, I am left with x minus 2. On the right-hand side, I do have to divide by 4. Each of these terms needs to be divided by 4. So 1/2 x divided by 4, 1/2 divided by 4, or 1/2 times 1/4 would give me 1/8 of an x left over. And then 8 divided by 4 is just a positive 2. All right, now that I have divided out the 4 on both sides, I'm just kind of taking a look, and I'm thinking about what I want to do next and how I can kind of differentiate myself here. Let's go ahead and let's clear this fraction, this 1/8. I know that I sort of chose going into that small fraction of 1/8, but now I'm just going to take 8 to clear that fraction. I'm going to multiply by every single term here just to get nice whole numbers. So I'm going to take this 8, distribute it across, again, everything, right? In an equation, if I do something to one term, I really have to make sure that I'm doing that equally on both sides. So 8 times x is 8x. 8 times negative 2 would be a minus 16. The 8, I chose the 8 because 8 will clear that 1/8 and we'll be left with just x. 8 times 1/8 is 1. And then 8 times 2 is a positive 16 over here. Alright, so now I'm left with the most, straightforward application here. I'm thinking that I really want my terms that have variable in it on the same side. I want my terms that are numeric on the same side. I like to just get rid of subtraction first when I see it, so I'm going to add 16 to both sides. When I do that, we have a 0 pair here, and I'm left with 8x on the left-hand side, and x plus 32 on the right-hand side. All right, from here I want to combine my terms, the 8x and the x, but of course, since I am moving something across the equal sign, I need to make sure that I'm considering the opposite operation here. So I'm going to subtract x from both sides, and I'm left with 7x equals, again I have a 0 pair here that cancels, 7x equals 32. 7x times 7 equals 32, so if I'm thinking about my related division fact, if 7 times a number equals 32, then that number must be 32 divided by 7. I like to leave my answer as an improper fraction. I feel like I'm totally okay with that. I encourage my students to keep it because there's no context here. There's no real world application where I need to know how many holes I have. 32/7 does the job for me. It cannot be simplified, so we will call it a day. Give a little smiley face and we're good to go.